Right, I'm back with some hardcore maths for you. Bing chilling. Happy holidays. So I saw this TikTok recently of this maths challenge about if you can solve this, you can be part of a disruptor. You know, Keir Starmer in the UK, the UK Prime Minister was posting some math challenges. And if you can solve this, apparently you can be part of the team of disruptors. And I thought, you know what? I'm just gonna give this question a shot. It was quite an interesting one because it gave you, okay, so you had this square here, and then the area was 36 pi, something like that. And then there was another square here. And then there's another smaller 2 squares here. And the area of this square was 5. And if I remember correctly, the question was, so the triangles were here. And then this one, I think, went all the way down here. This one went here. And then you're asked to find the area of that triangle. And it got me thinking, because squares, the beautiful thing about squares is that, you know, all 4 of the sides are equal, and all you really need to know is that, length times width equals the area. That's it. And for a square, because the width and the length are the same, that becomes that, and then L squared is your area, and that's about it. So I thought to myself, okay, maybe what we can do here is we could figure out, I don't know, like a bigger triangle minus a bunch of smaller triangles. And I thought of doing this. So if I were to make this a little bit longer, this pen doesn't work. Let's use this one. We'll go with this. Just gonna extend this out here, and we're gonna start labeling, giving it some names here, I guess. We'll call this side A. We'll call this corner B. We'll call this corner C. And I suppose where this middle is over here, let's just call this O for now. Okay, so immediately looking at this long diagonal, this and this, I've got a couple of things. I've got that big triangle over there. And really, this shaded area is the big triangle minus this sort of like white area here. But what's interesting about this is you could actually subdivide this even more into something like this. I mean, it's not drawn to scale, but you can kind of see how it kind of breaks up the diagram. So my first thoughts were, okay, if this is 5, then the side, because this is square, this is square, square, square. If this is 5 here, right, then one of these sides here has to be root 5. Root 5. Because root 5 times root 5, remember length times length, that gives me 5. Okay, so that's the beautiful thing there. That's 5, root 5, root 5, root 5, and then that has to be root 5 as well. So really, we can think of it as this red triangle here. We're going to call this red, where's my highlighter? We'll call this red thing here we'll call this triangle AOC, okay? And then we are gonna call this little orange triangle over here orange bit here, triangle ABO, and then I'm going to use purple guy over here, guy. This one here is triangle BCO. BCO. So really, we can say that I guess this red color triangle over here, triangle AOC, triangle AOC is the big triangle ABC minus triangle ABO minus triangle BCO. Okay, so we've clearly defined some triangles over here. So now all that's left is to figure out what the areas of these triangles are. So let's think about this. Okay, so if that's root 5, I need to know what this side is over here. But I know that this whole length here, well, if this area is 36 pi, then one of these sides, well, it has to be root of 36 pi. And this is root of 36 pi as well, right? And root of 36 pi is simply, well, square root of 36 is just 6. So it's 6 root pi for the side length of the big square up top. So this is root 5 here. I guess this is just simply 6 root pi minus the whole length minus this bit over here, which is just root 5. And don't forget, these are all numbers already, but we're just putting them in surd form, so it's just a bit easier to manipulate. Okay, I've got the base length here. Well, if that's root 5, then this bit here has to be root 5 as well. Okay, let's think. Okay, so if this is a square, and this length over here, well, this length is 2 lots of root 5, so this has to be 2 root 5. So this right here, that's 2 root 5 as well. Okay, we're starting to define a few things here. Okay, what's next? Well, that means then this here has to be 2 root 5 as well. And then we've already established that this bit here, that's 6 root pi. Okay, do we have all we need? I actually think we do. Okay, cool. So let's start by finding, I guess, an easy one. We'll do this bottom one over here. So when it comes to a triangle, okay, this is B, C, O, and that's a perpendicular height here. It's very important to note that for a triangle, the area of a triangle will always fit into half of a rectangle or a square. Okay, hence your equation for the area of triangle is half times base times height, your perpendicular height. So in this case, because I know my base, that's my 6 root pi minus root 5. I know my height, well, that's that bit there, that's root 5. Then I could say that the area of triangle, the purple triangle BCO, is just simply half times base, which is my 6 root pi minus root 5, times my perpendicular height, which is root 5. Okay, so it's looking all pretty good so far. So I've defined this so far. Let's define the orange triangle there. We're going to go that bit of a sketchy wedge over there. The whole length here, that's this guy, and this guy all together. So it's 6 root pi plus 2 root 5 plus root 5. And putting that all together, it's just simply 6 root 5 plus 3 lots of root 5. And then all I need is my perpendicular height over here, but we know that, okay, because that bit over there is this bit minus root 5. And if that's root 5, then I wonder, would it stand to reason that this bit over here, our perpendicular height, that is 6 root 5 minus root 5, take away root 5, right? Has to be, right? So therefore, that bit over there, that's 6 root pi minus 2 root 5, negative, negative. Okay, so we've defined a perpendicular height. We've defined the base. So I could say that triangle ABO is simply half times the base over here, which is 6 root pi plus 3 root 5 times my perpendicular height, which is 6 root pi minus 2 root 5. Okay, nice. That's my orange triangle there. So then what we need is our big triangle here, triangle ABC. So triangle ABC, well, that's a nice, simple triangle there. So it's just half times the base, which is 6 root pi, take root 5, that's my base, times the height over there, which is, we found that out just now, 6 root pi plus 3 lots of root 5. And there you have it. We've identified some numbers here. We've defined the 3 triangles, 1, 2, 3, and therefore the red triangle is just the big one minus these 2. Okay, so let's put it all together here. Right, where do we begin? Let's do BCO. Let's start with this one here first. Okay. So triangle BCO is half times, well, this minus this times this means this times this, this times this. So I'm going to go 6 of 5 pi, because that's an interesting identity there. Anytime you do like root A times root B, it's the same as the square root of the product. Okay, so that's that. And then minus, root 5 times root 5 is just 5. So we're all good there. Okay. So then that becomes 3, half of 6 is 3. 3 root 5s take 5 halves. Nice. Okay, so that's BCO done. Let's do ABO. Okay, so ABO. This looks like what we did in year 9 quadratics, or well, not quadratics, like binomial expansion. So when you've got two terms in the bracket times another 2 terms in the bracket, you've got, when you're expanding these brackets, you can use what's called the I guess they call it FOIL or something like that, but I remember it as whatever's inside gets multiplied by each term on the outside. So this is multiplied by this gets multiplied by this. And then this gets multiplied by this gets multiplied by that. Okay, so let's just go ahead and do that. So I've got half times 6 pi and 6 pi. Well, that becomes just 36, isn't it? Because, well, 36 pi, because root of pi times root of pi is just pi. And then I'll do take 12 root of 5 pi. Okay, so that's sorted out for the first 2 terms. And then this one over here, I'm going to go plus, it's 18 5 pi. Plus times a minus is a minus. 6 times 5, which is 30. So let's change that up. Because root 5 times root 5 is just 5. That's 30 over there. And okay, looks quite nice. Can we simplify this? Yes, we can. So I'll go half times 36 pi less, well, that's negative 12 plus 18 is 6. So plus 6 root 5 pi, take 30. And then simplifying all of that, well, just half of whatever's inside here. So I would have 18 pi plus 3 root 5 pi, take 30 on 2 is 15. Okay, looking good. And then now finally, triangle ABC. Same thing, I guess, because we're just doing the binomial expansion over here. So I've got half times, let's open it up. 6 pi is 36 pi. And then plus 18 root 5 pi. Take, well, we did that just now. 6 root 5 pi. And then minus 3 times 5 is 15. Okay, can I simplify this? Yes, I can. Half times 18 lots of this takes 6 lots of that, and it's 12 lots of that. So it's 36 pi plus 12 lots of this nonsense over here. Take 15, and then half of everything. So I've got 18 pi plus 6 lots of this stuff here. Take 15 on 2. Okay, we've got the big triangle, we've got the orange triangle, we've got the purple triangle. So we just need to take these two away from this guy. So let's see what happens. All right, so I would have triangle AOC, which is what we're after here, is simply this guy, which is 18 pi plus 6 root 5 pi, take 15 on 2, less these two guys. Okay, so less 18 pi, don't forget the bracket there, plus 3 root 5 pi minus 15 minus this guy over here. 5 pi, take 5 on 2. All right, we're looking very good here. So now, with the opening of the brackets, I've got 18 pi plus 6 lots of root 5 pi, take 15 on 2, take 18 pi, negative and a plus is a negative, take 3 lots of root 5 pi, negative is a positive, plus 15, take 3 5 pi, negative, positive again, plus 5 on 2. Okay, so putting it all together, let's see. 18 pi, well, that cancels out, so that bam, that's done. 6 lots of this nonsense here, take 3, lots of this nonsense is 3 left. 3 left, take, oh, that's nothing. Bam, oh my goodness. Then, so what simplifies then is this guy, and this guy over here. So putting it all together, I've got triangle AOC is negative 15 on 2 plus 15 plus 5 on 2. Negative 15 on 2 plus 5 on 2 here is really negative 10 on 2 plus 15. Is that correct? Yeah. And what's that? Negative 10 on 2 is 5. Negative 5 plus 15 equals to 10. I think that's your answer. So it's 10 units there. Bit of hardcore maths for ya.